Right, so today I'm going to do a quick demo of 3 different molecular visualization apps. I was happy to find out when I tested them that PyMol does actually work. It may have a few limitations because we don't have the fully licensed version of it. It may put like a watermark over your exported images, but that's not a big deal because I don't ever use PyMol to produce finished publication quality images. I use it just for creating reference images that I can then redraw somewhere else. I'm going to show you VMD, even though, as I'll point out to you, I don't like it. It's a very challenging, awkward program. I tested it this morning or earlier today, very briefly, and it was struggling to open any of the molecules that I tried to open, which has always been a problem with VMD. So we may skip that one entirely. I'll open it and try to show you what the interface looks like, but it's always been very problematic. It always has trouble opening some of the molecular model files that I try to open in it. So I'll probably spend more of the time focusing on Chimera, which is the one I normally use in my own work anyway. And then I'm going to demonstrate how we would use that to create a picture of a molecule in Illustrator. So we'll generate a reference from either PyMol or Chimera, and then illustrate it in Adobe Illustrator. Right, so something you're going to need for today's exercise is you're going to need a folder filled with PDB and mol files. And hopefully you remember from last time that these are the 2 most common file formats for saving 3D molecular model information. If you open up some of these, you'll see lots of PDBs, and occasionally there's a mol file thrown in there as well. So these are located in the course share. So you want to go to, from your desktop, go to the Go menu, connect to server. I don't know if this is going to pop up automatically for you. If this is the last server that was opened on your computer, then this may pop up for you. I'll read you the URL, although it may be hard for you to get this. If those of you who are on Zoom should be able to see it, but it's smb://cad-files.main.ad.rit.edu/courses. And when you connect to that, it may ask you to log in. I'm already logged in, which is why it opened for me automatically. And you need to go to current semester, find my name. You'll probably only have one course section showing up. If you go in the public folder, there's this folder of sample PDB and mol files. You can just simply copy the entire folder onto your desktop. They're all very small files, so it should copy almost instantly. Right, so I've already copied that on here. So I have a folder of biological molecules, drug molecules, some nucleic acids, and some proteins, and then some just interesting miscellaneous things. We're going to focus just on the biological molecules or the drugs today, and we'll come back later and get into some of these more complex things like nucleic acids and proteins. Right, so.
Here, I'm gonna hop on to it.
Okay, all right. So I'm going to go ahead and open up. Maybe I'm just going to get VMD out of the way right away because that's like my least favorite molecular visualization application, and it's already giving me trouble today. So we'll see if I can get anything to open in here. So it should be in your applications folder, VMD 1.9.4. You select it, and right off the bat, it does something a little strange. It's not like most other applications that you run either on a Mac or on Windows. It actually has to run inside sort of an emulation program on the Mac. It actually opens up this thing called Terminal and runs a bunch of code in this terminal application. So this terminal application is just sort of open in the background And then VMD is running inside of that. VMD itself has a couple of windows. We have our display screen here, which I'm just going to make a little bit larger so we can actually see molecules if they bother to show up. And who knows why they have this rotating 3D VMD thing up there. And then there's the VMD main window, which has these different commands in it. Under File, in order to load a molecule into the application and actually be able to see it in that window, we have to go File, New Molecule, and it opens up this molecule file browser. And if we want to search for a molecule that we have on our computer, something that we've downloaded either from the sample PDB folder or something that maybe we've downloaded from one of the databases on the internet, you click the Browse button. And on my desktop, you want to find your desktop and double click that. And here's the sample PDB and mol file folder that I copied over to my desktop. Let's just for kicks, let's go into biological molecules and see if any of these work. I tried vitamin E already and that didn't work. Let's try cholesterol. So I'm going to click OK. And VMD is supposed to recognize the file type. So notice that the particular molecule I chose is called cholesterol.pdb. It looks like VMD has actually successfully recognized that it is in fact a PDB file. Sometimes it doesn't do that. And if this file type window doesn't match what the actual file type is, it's definitely not going to open. And if I click on this little pop-up menu here, these are all of the different file types that VMD will supposedly open. And so there has to be an exact match. If I was opening a mol file, I'd have to make sure that it was actually set to MDL mol2, or there's actually a different kind of mol file in here. But hopefully, because it at least recognized that this really is a PDB file, maybe it'll actually work. So now I'm going to click the load button and that should load it in our window. Maybe, hopefully. Okay. And this is a common problem. It didn't give me an error. It said, okay, I loaded your molecule. I don't see it. A molecule there. Yeah, and when I look at the VMD main window, it actually says that it loaded cholesterol.pdb, but it says it consists of 2 atoms, which I know is definitely wrong because cholesterol is a much bigger molecule than that. So I don't know what that's all about. Let me try 1 or 2 more and just see if I can actually get one to open. Let's try vitamin B12. This is a different file format, so this is a mol file. Yeah, it thinks it should be a Sybil mol file, which I don't think that's right. Let me try it anyway and see what happens. Now it's actually giving me an error, unable to load. So let me try changing this to an MDL mol file. See if that makes any difference. Nope, doesn't like the file at all. Let's try one more and then we'll give up. Let's see, browse. Let's see, maybe if I go to a different folder. Trying to figure out how to back up here in my, well, I'm just going to pick another one at random here. Let's try NADPH. If this one doesn't work, I'm just going to call it quits. All right, see now, NADPH.pdb, and yet it didn't recognize the file type that time, so I got to figure out where in this ridiculous list protein data bank files are. PDB, right there. Try one more time. And why did it say, why is it saying cholesterol? It's not what I chose. All right, now it seems to have just crashed. So that makes my decision easy. We're just going to move on. I know people who actually like this application. It's produced at the University of Illinois. And so the folks at the University of Illinois at Chicago, their biomedical visualization program, they swear by it. But not sure why, because it doesn't ever seem to work for me. All right, so moving right along. Next one we're going to look at briefly is PyMol. PyMol works better. PyMol behaves. Um, when you first open PyMol, you may get a little message that says this is an application downloading from the internet. Do you want to proceed? And then, just say okay or say yes to go ahead and proceed. But then you're going to get to this window. I think I may have mentioned briefly before that PyMol is one of numerous applications that used to be completely free, and now it's behind a paywall. You have to pay for it. They still let you download it, but you have to pay to get a copy of this thing called an activation file, and or this license file. And you used to be able to just download the license file for free, especially for educational use. But now they don't even let you download a free educational license. If you did have the license for it, you would click here and then you would locate the file and it would fully activate it. But we're just going to skip activation, and that'll still let us use the software, but perhaps with some limitations. So here's the PyMol interface. It's this one large display window where the molecules will show up, and then we'll talk about some of this other stuff later. And then a bunch of your standard menus across the top. So I could go to the file menu and I could say open, or I could simply, if I have the sample PDB and mol files open on my desktop, I could simply grab any of these and just drag it right into the window. And hey, it actually opens. Well, I just realized something a little odd about this molecule. Any notice anything weird about the molecule when I rotate it sideways? Completely flat. Now there are parts of this molecule that are flat. You recognize this symbol over here, the dotted lines. That tells me that's a benzene ring. That part of the molecule is actually flat. But this nitrogen right here, represented by that blue stick, that should be adopting a pyramidal configuration. So the 3 bonds attached to that nitrogen should be a pyramid, and they're not. So I don't know if that's got something to do with the particular file or something else going on. Let's see here. It may just be that one file. So let's see. Under actions here, I think I can completely delete. Yeah. So if you look to the right of the image window, you'll see that acetaminophen actually shows up here. And then there are these buttons next to it, A, S, H, L, and C. And under the A button, I can just choose to completely delete the object. So let's try one of these other ones. I'm a big fan of caffeine, so let's try that one. Okay, that one's, yeah, that's still too flat. I know there's these methyl groups. These are CH3. Those are in the right configuration, but again, all of these nitrogens in here should be pyramids. These are not benzene rings, so these should not be completely flat. Try another one. That's better. All right, once again, there's a benzene ring in there, the little dotted lines inside a 6-sided ring, but all of the other atoms have actual bond angles to them. One thing I hate about PyMol is that it doesn't always follow the standard CPK coloring scheme, the element coloring scheme where carbon should be dark gray. Everything else is fine. I mean, there's no nitrogen in here, so there's nothing blue, but we got some red oxygens and we got some white hydrogens. But I don't know why it's coloring the carbons pink. I can fix that. I'll show you how to fix that later, but it's just always strikes me as kind of odd that it would do that. All right, so at least now I've got a molecule that's not flat. So if I go over here to my where it says ibuprofen, when I click on that first button to the right of the name of the molecule, the A is for the action menu. And a lot of this stuff I don't ever bother to use. There are a couple of things here that are handy, like delete object is always a handy one if you just want to get rid of something. One that's often very useful is there's a submenu here for hydrogens, and then to the left, one of the options under hydrogens is to add. Now, why would I ever do that? Well, sometimes even these 3D molecular model files come in without all of their hydrogens. You'll have carbons that don't have the right number of bonds. So what this command does is it actually calculates the valence for every atom and makes sure that it has a full valence. And if it's got carbons that only have 1 or 2 bonds on them, it adds the missing hydrogens. This molecule looks fine. I don't think there's anything wrong with it. So if I click add, it shouldn't do anything, hopefully. Right, it did nothing. I don't know of a good example off the top of my head of one that is missing hydrogen, so I can't really demonstrate it, but just be aware that if you ever did bring a molecule in and it seemed like it was missing a bunch of hydrogens, you could easily add them. There's another one here that we may come back to another time. There's a command called remove waters. Now, what in the world would that mean? So when you do X-ray crystallography on something like a protein or a nucleic acid like DNA, oftentimes there has to be water present. The molecules have to be hydrated. I mentioned the other day that this was the big breakthrough that Rosalind Franklin made, as she recognized that the DNA had to be hydrated in order to maintain its proper structure and get good X-ray crystallography data. But what happens is that those water molecules actually get incorporated into the crystallographic file, the 3D file. So if you open, it's not going to happen with this. This is a simple small molecule, this caffeine molecule. You're never going to have water come in with something like this. But if you open a protein or nucleic acid, and you notice like a lot of random little red dots floating around, those are probably the oxygens that are parts of the water molecule. So you simply select this thing here that says remove waters, and it just gets rid of any water molecules that come in. Whoops, I just accidentally deleted my molecule. That was dumb. What was that, caffeine? Is that right? Oh, no. Ibuprofen, right, thank you. I tried caffeine once and it didn't work. All right, so here's, yeah. Now the carbons come in as salmon. Yeah, it seems to. Like, usually it starts out with bright green, and then it goes to something else and something else and something else. It's never gray, which is what it should be. But yeah, it seems to just sort of cycle through random colors. All right, so is there nothing else under here that I use? I mean, there's obviously a lot of other stuff, but nothing that I use. The S menu is for show. What that means is basically this is how you turn on different types of models to look at. So you could do a wireframe, a stick model, which is what we're looking at right now, ball and stick, space filling or sphere type model. So let's see, if I do wire and lines, it's not going to look any different. The reason for that is that right now, by turning on lines, which is like a real thin wireframe kind of model, these thick sticks are still there, so they're kind of hiding the lines. There's another menu right next to the show menu, which is the hide menu, and I have to hide. Let me just try hiding everything, and then I can turn on these individual things. So here's the whatever they call it, a wireframe or line model. And then I can add, okay, that doesn't do anything. Let's see, what do they call? I don't know why they call it licorice, but here's a sticks model. By the way, that wireframe model is still in there. It's just being hidden. So I might want to make sure that I hide that so I don't have basically two models superimposed. I could also go to spheres, and that's our space filling model or CPK model. And of course, I can rotate this around. I can just with the mouse, just pick it up and rotate it around to different orientations. Some of these other options like ribbons and cartoons, those are only going to be available for something like a protein that would have a backbone model or ribbon model for secondary structures. I think I can add a surface. Normally, we only use surfaces for things like proteins, but it sort of puts a surface over there. Now, if I hide the spheres, then you can see I get this kind of rough, faceted surface. We hide that. Still got our sticks in there. So anyway, you can turn on different representations with the show menu. You can hide them with the hide menu. Just a couple other quick things I'm going to show you in PyMol because, again, it's not one that I use very often. Going up to the menus up at the top, there's a display menu, and I can change things like the background color, change it to white. I could make it gray or light gray, whatever. It does. It's have pretty limited range of colors that you can choose from. I can change the color space from CMYK to RGB, although there's generally no reason to do that because, again, I'm not exporting publication quality images out of PyMol. I'm going to redraw them somewhere else, so it really doesn't matter. Something that may be helpful is there's an option down here under the display menu called orthoscopic view. You remember in Horos, we had something similar. We had, or I think they called it orthographic, orthoscopic, basically the same thing. It's sort of a way of looking at things in parallel without perspective. And then Horos, you had the choice between perspective or orthoscopic. Here in PyMol, the perspective view is the default. Whereas in Horos, the orthographic view is the default. So if you wanted an orthoscopic or orthographic view without any sense of perspective, you'd have to actually turn that on here in the display. And you might have noticed a very subtle difference in the appearance of the molecule when I switched. Probably if I put it into more of an extreme foreshortening, if I go back to the perspective view, this may make a little bit more of a difference. Yeah, it's still not a huge difference, but I tend to work in orthoscopic view. I think that's everything here under display. There's also a settings menu that has some useful things. One of the most useful is you can change the color settings. And this is where you can actually change the colors of the individual elements. And this is the only way to get carbon to look gray. So it actually has every single element on the periodic table in here. I'm just going to scroll down, select carbon, and it's telling me that carbon is supposed to be bright green, which is what it was the first molecule that I opened, but now it's cycled through pink and salmon and a few other things. Theoretically, I should be able to change this. If I make all of these numbers equal, if I make the RGB values all equal, that should be gray. Yeah, and it didn't work, of course. I tried it earlier when I was checking out PyMol, and the first time I opened a molecule and the carbons came in bright green, and I did this, it fixed it. But it was telling me a minute ago that carbon was supposed to be bright green still, and it's definitely not. It's salmon in color. So this just seems like a weird bug inside a PyMol. So it might work if you open the molecule for the very first time, you can go in here and change the color of carbon and then apply it, but it's not working. There might be a way to change that. The little menu to the far right of the name of the molecule, the one with the little rainbow, the C is for color. If I change that to color by element and choose this first option, it might work if we're lucky. And of course, that doesn't work either. So go figure. Yeah.
You change it closer to 1 and make all the numbers even, it's a lighter value. So I did it all to 0.7, it makes it.
Okay. Yeah. Huh. Well, let me try. Let me try Harper's suggestion and just if we change them all. I'm just going to put in some random thing here. All 0.5. And it doesn't like that either. So go figure. It's a very fickle program. But if if we ignore the fact that the carbons are salmon and we just make a sphere, like, oh, now it's not even doing that. Show spheres. Nope. All right, great. Don't know why it won't show sphere. Okay, and hide everything doesn't work either. It's pretty much decided that it doesn't like me today. That's all right. I don't like it either. And I think we're done. So let's go to an application that actually works reliably. I'm going to go ahead and quit PyMol. And I'm going to open up Chimera. Now, there are two different versions of Chimera on here. There's regular Chimera and Chimera X. We used Chimera X before to create the spike protein for our coronavirus. Chimera X is great for doing stuff like that. And it does molecular visualization just fine too. But I'm just going to stick with plain old Chimera this time because it's going to do everything that we need it to do for basic molecular visualization. So once again, it says it's downloaded from the internet. Say, yep, I want to open it. It's open. It's just was hiding behind my desktop. All right. So I'm just enlarging the viewing window. The only weird thing about Chimera, and it's not a bad thing, it's just odd, is the menus are duplicated. So there's a set of menus across the top in the regular Apple menu bar, and then all of those same menus are repeated in the actual image window itself. Makes absolutely no difference which one you use. So use whichever menu just is easier for you. So I'm going to go to one of these file menus. And I'm going to choose Open. And it opens up this separate little window. Go to the desktop. Yes. Go to that same sample PDB and mol file. Go to the drugs. And I don't know, let's try nicotine. I don't know why I have two nicotines in here, but open one. All right, that's a nice three-dimensional molecule. I mean, it's kind of flat-ish, but a lot of the bonds are not completely flat. This ring down at the bottom here must have some double bonds in it, which is why it looks flat. It's also why there's only one carbon, or excuse me, one hydrogen on each of the carbons, because there are probably double bonds in there. But the other ring does not have double bonds in it, and all of the carbons are fully saturated, and all of the carbons are forming nice tetrahedral arrangements of bonds. Now notice that Chimera also, for some strange reason, has decided, hey, let's not use gray for carbon. Let's use this tan. But at least I know this one I can fix, and it will actually behave correctly. So first, let me show you. Oh, I just went to the file menu, said open, and then navigated to my desktop and to that sample PDB mold file folder. First thing, but before I show you some of the menus, just a little bit about moving around and navigating in Chimera. If you just click with the mouse and drag, you can see that it rotates it in 3 dimensions. If I hold down the Command key and drag left or right, it zooms in and out, which is something that PyMol doesn't do. PyMol has a very awkward way of changing size. Hold the Option key, and it lets me just move around, just translate left, right, up, and down. So Option to move around and Command to zoom in and out. Let's see. One of the most important menus up here is the Actions menu, and again, it doesn't matter if you grab the top menu from the Apple, menu up there, or this Actions menu here. They're exactly the same. Under Atoms and Bonds, we can decide to show the atoms or hide them. Of course, in this case, if I hide the atoms, everything goes away. So I have to go back here to Atoms and Bonds and say show the atoms and bonds. But now I can also decide how I want to show them. Do I want to show them as just a stick model, which is what we have right now? I can change it to ball and stick, which you can see adds just little spheres at the corners where the atoms are. Or I can change it to a sphere model, which would be a space filling model. We can go back to just ball and stick for now. I think under atoms and bonds, rings, there are some options under here under this rings submenu for what's called aromatic disk, aromatic circle. An aromatic is another term that's used for benzene rings. So if I choose aromatic disk, it puts a little circle in the middle of this ring over here. This is not really benzene because it's got a nitrogen in there, but it's mostly benzene, and it does have these double bonds cycling through. So the circle is one way of representing that. I could also go to atoms and bonds, rings, and say aromatic circle, which just adds this thin little line. So this is one way that I can actually tell that this is really a benzene ring with a bunch of double bonds that are cycling around between these 6 atoms here. Let's see. Under Actions, we also have a whole submenu for ribbons. Now, this is not going to do anything to this particular molecule because ribbons only works with proteins. it's going to give you a ribbon model, which is going to show the elements of secondary structure. It's going to show alpha helices and beta sheets. So we'll come back and talk about representing proteins in Chimera at another time. Today, we're just focusing on these little small molecules like drugs. So none of this stuff is actually going to work. I could add a surface. Surfaces work on any molecule. So I just go to Actions, Surface, and Show. Kind of a ugly, blocky surface, but it is a surface. There are some things I can do to that surface. Right now, it's set to a solid surface, but I could also make it a mesh surface, so it looks like a wireframe mesh. And then since my ball and stick model was still there, it's visible inside. I can also change this to a dotted surface, which is not really showing up very well. Usually it looks a lot better than that. You might be able to tell that there's some tiny little dots. Usually you actually get what look like nice spheres with dots on them. If I go back to a solid surface, I can also change the transparency of that surface. Just pick some number between 0 and 100. And it makes the solid surface partly transparent. So again, the ball and stick model shows through. And go ahead and hide the surface though, because I don't really need it. Also under Actions, there's a color submenu. Now, if I simply choose any of these colors, it's going to just change the entire molecule to that color, which probably no good reason to do that here. But later on, when we start playing around with things like proteins, if you have a protein that consists of maybe multiple amino acid chains, like hemoglobin, you can actually select the 4 chains and color them all differently if you wanted to distinguish the chains. For something like this molecule, I probably don't want to choose one of these solid colors and just to apply the whole thing. I'm going to choose color by element. And this should now change the tan carbons back to gray. And it does. So when you open something in Chimera, and it gives you those tan carbons, if you really want them to be gray, you just say Actions, Color, Color by Element. Now, it turns out there are a lot more color options in Chimera, including the ability to change the color of the background of the image. But to get any of the other color options, you have to go all the way down to the bottom of this color submenu. And there's an option down here that says All Options. And what that's going to do is it's going to open up a little floating window with more color options in it. Now, I can still simply click on one of these colors on the left and change the whole thing. Or I could click down here where it says Other Colors, Colorings, Color by Element, and we go back to our CPK color scheme. But also notice that part of this color action window says Coloring Applies to, and then there are a bunch of little check buttons underneath that. What this allows you to do is it allows you to apply the color only to certain parts of the molecule or only to certain things. Like, for example, let's say we had a protein that had a ribbon model. We could say, I could pick any color from here and say, apply that color only to the ribbons. And if there was something else shown, if there were individual atoms that were visible, it wouldn't affect the atoms. If I had a surface on here, like, let me go ahead and do that. Let me go back and add the surface back on here. We'll do a solid surface. It's still set to be partly transparent, right? Because I still have the transparency set to whatever it was, 60%. But now, in my color actions, if I say Coloring Applies to Surfaces, and I now click the orange button, it's only applying that orange color to the surface, because that's what I checked off on the right side of this window. The rest of the molecule, the ball and stick version, is still colored by element. The default is that it colors all of the above. So now if I choose all of the above and I pick something like cornflower blue, it applies that to the surface and to the atoms. If I go back and choose just atoms and bonds and say color by element, since I've selected only atoms and bonds up there, I get the atoms and bonds back colored by element, but the surface remains blue. And then if you want to change the background color, the only way to do that is in this color actions window. You actually have to choose background color, and then you can make it light gray or white or something hideous, whatever you want. So that's the only way to change background color in here. Go ahead and close that. Go back and hide my surface again. Back to actions, surface hide. There's a whole lot of other options here in Chimera. It's a very powerful application. There's a whole tools menu here that has all kinds of other tools. Actually, let me show you a couple things under here because this may be useful. Under tools, under viewing controls, regardless of which one of these things I choose, it's going to bring up the same little window. I'm just going to click on side view. We're not going to use that one right now, but notice when I choose any of these tools that say viewing controls, we actually have tabs for camera, side view, rotation, effects, lighting. We'll come back to side view another time. Camera. I guess the one thing that's useful here is this is where you can actually change between a perspective view and an orthographic view. So again, you have to go to tools, viewing controls, pick any of these, and go to camera. And under the camera is where we're going to choose our projection, and we switch between perspective and orthographic. Again, it shouldn't make much of a difference in this particular molecule, but I generally like to work in an orthographic view. So that's an important thing to be aware of to change. You can also set this to do a stereoscopic view, where you get two images that you can look at with stereoscopic glasses and create a 3D image, but that's not something that we normally do. We just stick with plain old mono vision. See, rotation, we don't need to worry about that. Effects, we'll come back to that later. The lighting panel under the viewing controls can be helpful because this is going to allow you to determine where your light source is. So do you want upper left-hand lighting, or do you want some other kind of lighting? And do you want to change the intensity of the lighting? And so when I click on the lighting tab, I can change between single light, or actually I can go to ambient lighting, which is almost like a cartoon shader. It colors everything uniformly with no highlights or shadows. I can go to single light source, which is basically a single spotlight, or I can go to a 2-point light. And when I do that, I get these little things that, I don't know, they look like little thumbtacks, little push pins. And I can actually grab these and rotate them around the sphere, and it changes where my light source is coming from. So the green one is known as the key light. That's our primary light source. So I'm going to stick that in the upper left. And then the purple one is a fill light. And you remember we did that when we created our coronavirus. We added a secondary light down in the bottom right to kind of fill in the shadows a little bit. And the term fill light comes from the world of photography. You can move the fill light around, although the fill light is a lot less intense, so it doesn't do a whole lot. But I think when I drag the fill light all the way down to the bottom right, you might be able to tell that we're getting a little bit of reflected light hitting the bottom of the atoms. So you can play around with the location of these two lights. I think there's even more. There's like there's a 3-point light, but I'm not going to bother with that. We can also change the overall brightness. So we can make it really dark. We can make it, like really overly exposed or find some happy medium. You can also change the amount of contrast. Right now it's set pretty high. I can reduce the contrast so I don't get such strong highlights or shadows, especially the shadows. I can also change the ratio of intensity between our key light, our primary spotlight, and our fill light. So the higher I go on the key to fill ratio, the more dominant the key light is and the less important our fill light is. If I drop this way down, now our fill light becomes a lot stronger, at least relatively speaking, kind of a one-to-one relationship. So I'm going to put this, somewhere around here. It's not that big a deal. I can also change the shininess. Now this is actually affecting the shininess of the material. So we can kind of pretend that our atoms are made out of hard plastic or make them more soft. And so the sharpness is going to determine like how strong the highlights are. This is almost sort of a cartoon image here. We can reduce the highlights, so make them tiny little spot highlights. We can change the reflectivity. If I set that down to 0, then we don't get any specular highlights. So this would be like having more of a soft diffuse lighting on the object. Or if I crank the reflectivity way up, I get these really, really hard, bright highlights. I'm probably going to set the reflectivity down a little bit so we don't get really overwhelming, obnoxious highlights, something like that. So, if you get a chance today, maybe play around with some of the lighting options. Under effects, there's something called depth cueing, which you may have noticed as I was rotating the molecule around. As some part of the molecule gets farther away from us, it kind of fades. That's what depth cueing means. If I wanted to, I could turn that off. And so we no longer get that sense that things are disappearing. It's another term for that artists use is atmospheric perspective. The idea that things that are farther away from you appear kind of faded. But I kind of like the depth cueing. Definitely helps you understand the 3D form of the molecule. We can turn on shadows. Now there are already core shadows on these atoms, but if I turn on this kind of shadow, it's actually going to create cast shadows. And it didn't do a whole lot. You may have noticed a couple little cast shadows popped up in the molecule. If I had a bigger, more complex molecule, then the cast shadows might be a little more noticeable. I'm going to keep those turned off. And the final thing here I'll show you is silhouettes. A silhouette is a way of adding a stroke around the edges of the object. So you can add a black outline, or actually, I think you can add any color you want. I think the default is black. So I don't know if you can tell, but there's a very thin black outline around all these atoms now. And if I increase the width of that, go way up to something like 6, even that's not that big, but you can start to see there is a black outline. So we could go even higher than that. Oops, yeah, that's fine. And it still doesn't get all that big, but if you prefer that look, if you like the look of having a black outline on the atoms, you can do that. Now you could change the color. You click on this little color box here, and you get an RGB color editor. So I could do something like this, which I don't know. I don't really see the point in putting an orange outline on my atoms, but you could do that. I'm going to set this back to pure black. Just push the RGB values all the way down to 0. And I'm just going to go ahead and turn off the silhouettes because I don't really need them for today's exercise. So that's a real quick run through of the options here under viewing. And there are other things under tools that we'll come back to another time. when we get into, visualizing proteins more, more complex molecules, some of these other options here under the tools are going to be more important. So last thing I'm going to do, and then we'll take a little break, is I'm going to change my representation from a ball and stick model to a sphere model. I'm going to have to make it smaller, so hold Command key and drag. One thing I'm noticing is that in this sphere representation, the hydrogens are unusually small. I know in some applications, the hydrogens are bigger. And I don't know if I had changed this setting at one point and never reset it, or if it's just, I don't know, not sure why it's doing that. I'm trying to remember how to change the relative scale of these things. Tell you what, why don't you all go ahead and take your break. Go ahead and take 10 minutes or so, come back about 3:10 and we'll resume. I'm going to stop share and stop the recording while I fiddle around and see if I can figure out how to make those hydrogens look bigger. All right, so while you all were on break, I went ahead and opened up a different molecule, just a little bit more interesting, although I never could figure out where the setting was to change the relative size of the spheres. I know that hydrogen is supposed to be significantly smaller than carbon, oxygen, nitrogen, and that bright yellow one is sulfur. But these strike me as quite small, but I'm not going to worry about it. We'll work with it. It's not even so much that they're too small. It's just that the amount that they're overlapping with the carbons, the fact that they're like completely swallowed up by their neighboring atoms, is just a little different than some of the other applications represented, but I'm not going to worry about it. So just last quick thing I want to do with this molecule is I do want to go back into the colors and change a couple things. So I'm going to go actions, color, bring up that all options window. I'm going to change the color by element because since I opened a new molecule, it brought the carbons in as tan, and I want to make sure that they're gray. So just color by element. And then I also want to get rid of the black background. I'm going to just make a white background. So to do that, under the right-hand side where it says coloring applies to, say choose background here, and then I'm going to pick white as the color. So that gives me the atoms on a white background. So now I'm going to save this as an image. And you just go to the file menu. There's a save image option. Brings up another separate window. We got to figure out where we're going to put it. I'm going to put it on my desktop. And whoops, didn't mean to do that. Don't know why it closed like that. Save image, desktop. Okay, that's what I want. File type really, for what we're going to do, we're just going to drop this thing into Illustrator and then draw over it in Illustrator. So the file type for your reference image doesn't really matter that much. Oh, I'm sorry. By the way, one thing I did forget to mention. You do want to rotate the molecule into some orientation where you feel like you can see all of the atoms, or at least most of them. The problem with space filling models is that since they're a bunch of solid spheres, sometimes part of the molecule is hidden in the background, and there's simply no way to see all of the atoms at once. So just get it into a position where you can see most of the atoms, or at least so you think you can see most of them. I mean, this is okay here. And then do that save image. And I forget I think this is penicillin. Penicillin, they're missing an I. And so the file type doesn't really matter that much. I mean, I wouldn't use EPS, but JPEG, PNG, even TIFF, pretty much any of those should work. I'm going to tell it to use print units so that I can enter an actual size in inches. Right now, it's just set to export something in a certain number of pixels, but I don't have a intuitive sense for how big that actually is. So I'm going to say use print units. Okay, so it's an enormous image. I don't need anything nearly that big. I'm going to make something like, I don't know, 8 inches in width. And when I hit the tab key and move into the next space, it should keep the same aspect ratio. So it reduced the height proportionally. And then resolution, again, it doesn't matter a whole lot because we're simply using this as a reference to draw on top of. So it's not a big deal if it's a low res image. I'm probably going to make it higher res just to make sure I've got sufficient detail to be able to work on top of it in Illustrator. But again, this would only matter if we were actually exporting from Chimera to create a publication quality image directly out of Chimera. So I'm going to go ahead and save that to the desktop. And hopefully it did that. I can go ahead and quit Chimera. If you want to just close the molecule in Chimera, you want to go to the file menu and say close session. So that closes that one molecule. You could then reopen another one, but we're done for now. So I'm just going to go ahead and quit out of Chimera completely. Just hide Illustrator briefly. Get a lot of clutter on my desktop. But yeah, there's my penicillin image. Apparently it did, for some reason, it saved one that I didn't intend to save, but there's my ping file on my desktop. All right. So we're going to then go into Illustrator and we're going to make one of these. We're going to make a space filling model in Illustrator using radial gradients to create the spherical appearance of these space filling spheres. Creating a circle and putting a radial gradient in it is pretty easy. Although I'm going to show you, I'm a little bit OCD about how I do it. I'm going to show you my preferred method, how I would like to see you create these gradients. The tricky part, though, with creating one of these space filling models is getting the intersection of the atoms. It's not enough to just stack these circles on top of one another. In order to create the appearance, for example, of this ring of carbons right here, notice if I select one of these, oftentimes you have to trim them. Now, some of them are still just perfect circles. Well, no, that one's not quite a perfect circle. That one's been partially trimmed. Doesn't look like this one's a perfect circle either. There may be some here that are still perfect circles. Looks like this one is still a perfect circle. But a lot of these things have been trimmed off to create the appearance of how these things intersect and overlap with one another. So that's one of the tricks to doing this. So I'm going to just show you quickly a handful of student examples from previous years. You can see how they've created gradients that have a highlight, a midtone, a core shadow, and even a little bit of reflected light. Even the hydrogens, even though hydrogen is white in the element color scheme, we're going to use a light gray just to make sure that we can put a shadow and a highlight on it. As Professor Hintz is known to say, sometimes you can't put a highlight on a polar bear's ass. So if you want something to have a highlight and have a sense of 3D form, it has to have a little bit of value in it in order for the highlight to show up. Here's another one. These are very nice gradients. I really like the gradient on these chlorine atoms over here on the left. So notice how there's a nice bright highlight surrounded by a midtone, which is the actual color of the atom itself, the green, and then it transitions to a nice core shadow. and then a little bit of reflected light down in the bottom right. And it gives it a really nice sense of 3D form. And all of these atoms have that. Here's a carbon in gray, and whoops, need to do that. There's a hydrogen. Again, you can see how the hydrogen has a highlight, and it's actually got a fair amount of gray in it. And then, of course, shadow and reflected light. Here's a nitrogen over here. Another example. This one's got pretty nice gradients in it too. But again, you see how some of these atoms have to be sliced and diced in order to get them to look like they're overlapping. All right, so I've got a demo prepared to show you how I like to do this, how I like to approach these things. And instead of using the penicillin pink file that I exported earlier, I'm going to use this other one. I forget even what is, oh, this is ibuprofen. I'm going to use this to work on. You might be able to tell it's a pretty crude low res model. I think this actually came out of PyMol, which is why everything has this faceted appearance to it. But again, it doesn't matter because I'm redrawing it. A couple things about Illustrator that I think you're going to want to change. I mean, I set my desktop up a certain way. The grad students know this because I did a couple of Illustrator demos for them. I usually hide all the little panels on the right, and I just have a few palettes floating. Like I want my layers palette, definitely want my color palette. I never use this color guide thing. Definitely want the color palette. I might want the stroke palette in case I decide I want to put a stroke on the atoms. Usually I'll attach that to the color palette. I don't need transparency. Please don't use transparency. I can't imagine why you would for this anyway. Oh, and I definitely need my gradient palette. That's an important one too. I got color, stroke, gradient, and then my layers. Couple other things that I do. Some of these are just my preference for working. Others, I think there's an important reason. Like under the view menu, I despise smart guides. So I always turn them off. I find them incredibly annoying. That's where all these things keep lighting up and popping up in front of you. I don't like those. I also turn off all of these snapping things. Snapping to point, snapping to grid, snapping to glyph. I don't want things to snap. I just want things to be where I put them and not try to outsmart me. Couple other things I'm going to change. I'm going to actually change some things in the Illustrator settings. I'm going to go to Illustrator settings, selection and anchor display. It brings up this whole big panel of different kinds of settings that I can choose. I always prefer to turn this setting on, object selection by path only. Now let me show you what happens if I don't turn that on. If I have an object like this rectangle, and I'll just put some color in there just so you can see it better. If that's deselected, whoops, if that's deselected, by default, I can select this object by simply clicking anywhere inside of its fill color, and it selects the whole object. Or alternatively, I could select it by clicking on its edge on the path. I don't like to be able to select objects by their fill color. And it may not be that big a deal in this particular instance, but the reason I can't stand selecting objects by their fill color is, let's say I had a whole bunch of objects. Oh, and this darn thing drives me nuts too. I don't understand the point of that. Hide bar, thank you. Let's say I have a whole bunch of objects and I want to be able to quickly select these objects The easiest way to select all of these is to grab any of the selection arrows and simply drag a selection around them. Oops, but I can't. See, I'm trying to do this. I'm trying to just drag a selection around them, and then I can pick them all up at once. But if there's another object behind them, if I click in the fill color of that background object, it selects the background object. It doesn't let me select the other little boxes in the foreground. So if I go to the settings and I say object selection by path only and say OK, now if I want to select all those little rectangles, I just drag my mouse around all of them and I got hold of them all. And it didn't inadvertently pick up the object behind them. Now, the downside is that you have to be very careful about clicking right on the edge of the object to select it, but I prefer to work this way. So this, maybe it's just me, but that's a preference that I always change when I work in Illustrator. There's another preference that I change in Illustrator, which I think is going to be a whole lot more important for today's exercise. So one of the things that we're going to have to do today is we're going to have to trim some of these circles to make them look like they're overlapping. And the way I like to do that is I take the pen tool, and with the object selected, if you put the pen tool over a selected path, it changes to the Add Anchor Point tool. So notice when I hover over the selected edge, we get a little plus sign there. So I'm going to add an anchor point, and then I'm going to go over here and I'm going to add another anchor point to the other side. And then I'm going to delete a couple of anchor points. If I hover the pen tool over an existing anchor point, it gets a little minus sign, so it changes to a minus anchor point or delete anchor point. And I can do the same thing with this one. And you see what I've done very quickly by simply adding 2 points and deleting 2 points. I've cropped the edge of this atom a little bit so that it would look like it was intersecting with its next door neighbor. But sometimes when you do that, the curvature of this line is not exactly what you want. Maybe I need to drag that curve out a little farther, or maybe I need to pull it back in a little farther. And here's what happens when you try to do that in Illustrator nowadays. And this is, I say it's a new feature. It's probably been around for, I don't know, 6 or 7 or 8 years. But I've been using Illustrator for over 30 years. So this annoys me. I still consider it a new thing. So when I drag that edge, whoa, I get all kind of weirdness going on. My handlebars are all over the place. It doesn't look like a circle anymore. I've distorted it. Now it's a blob. Anytime you click and drag, and all I'm trying to do is simply extend that curve a little farther, it completely reorients the handlebars and just totally screws up my object. That's a relatively new feature of Illustrator. All earlier versions of Illustrator did not do this. They didn't behave this way. They added this and they thought this was a great feature, and the internet went apeshit. People were just blowing up the Adobe forums, including me. Like, why in God's name would you do that? It's like, that's the dumbest thing ever. And it totally screwed up my workflow. It screwed up my ability to create these kind of molecules. So it took them a while. It took them about 6 months, but then Adobe built in a workaround. You have to go into the Illustrator settings and change something, but you can change it so that it behaves the way it used to. So if you go back to the Illustrator menu, to Illustrator settings, selection and anchor display, it's the most obscure sounding option in here that you would never ever dream of choosing: constrain path dragging on segment reshape. Basically what it means is if you turn this on, the handlebars won't get all wonky on you when you simply try to drag a curve. So now watch what happens if I use the white arrow and try to move this little curve over here. I can just drag it and make it a little longer. The handlebars simply get longer. Or I can drag it the other way and make the handlebars a little shorter. I mean, it still kind of moves around a little bit, but at least the handlebars aren't rotating all over the place. The handlebars remain nice and straight. They just get longer or they get shorter. And so to be able to crop your atoms without totally destroying the shape, I think you'll find that it's really helpful to turn that on. So once again, that's under the Illustrator settings, selection and anchor display, turn on constrained path dragging on segment reshape. And keep in mind, if you don't finish this exercise today, I don't know that you'll have time to completely finish it today, but if you sit down at a different computer with Illustrator, you're going to have to change that setting all over again. Now, the reason I have two copies of my molecule here are that there are two general approaches to how to do this particular exercise. First thing I need to do is I need to just place my image in here to begin with. And let me go ahead and delete these and just show you how to place your image in here. You generally want to use the place command. I don't like to just copy and paste things into Illustrator. I like to go to the file menu, place, and then I need to find my image. And then you get a little thumbnail, and then you can simply drop the little thumbnail wherever you want it. Now this is way too big. This is an 8.5 by 11 page, and that molecule is 2.5 times the size of that. So I need to scale my molecule, my image a little bit. Now at least it fits on the page. And I'm just going to duplicate this to make my second one. So I use the place command to drop my reference image in there, put it on its own layer, and I'm going to lock that layer so I don't inadvertently pick it up. And now I'm going to create a new layer, which I've already done. I've created a layer here called layer 5 to start creating my art. Right, so I was starting to say that there are two basic approaches to how to do this project. The first approach is to simply draw flat colored circles and do all of the trimming and cutting and intersecting of the shapes, and then add the gradients later. Or you can start out with the gradients right from the beginning and put a bunch of these spheres overlapping one another and then trim the spheres. I don't care which way you do it. So if I were to try the first method, I'd want to create a circle for my carbons. And one of the tricky things sometimes is just figuring out how big is a carbon, because almost all of these are partially cut off. You know, all of these carbons are overlapping with their neighbors. So it's very hard to find one carbon where we can actually see the full, the full size, the full circumference of a carbon atom. I think there's one up here that I can get pretty close. I'm going to get rid of the fill and just put a black stroke on here and try to position that circle so it's roughly the same size as that carbon back there. Probably needs to be a teensy bit bigger. I'm just going to scale it a little bit. The idea is I'm just trying to get it to match the edges of that dark gray circle back there. Then I can give that a fill color, and I'm just going to give it a flat color fill. So since it's my carbon, I'm going to make it a gray. We'll go a little darker than that, just so I can distinguish it from the hydrogens. And then I'm going to just drag that off to the side. And every time I need a carbon, I'm just going to go and grab a copy of this and drop it in there. I may want to go ahead and make all my other atoms first, at least make one of them, and then I can just keep copying them. Here's an oxygen in red. So I'm going to draw another, whoops, that's not what I wanted. I want my ellipse tool. In the interest of time, I'm going to go ahead and use keyboard shortcuts because I do these Illustrator keyboard shortcuts in my sleep. So things like changing to the ellipse tool, I just hit the L on the keyboard. Let's see, this is going to be my oxygen. So we'll just make that a red. Drag that off to the side until we need it. And the only other thing I need for this particular molecule is hydrogen. You may have others. You may have nitrogen, you may have sulfur, you may have various things. So here's my hydrogen. Try to match that up roughly to the edges of that hydrogen atom. And we're going to put just a little bit of value in there. It's our polar bear's ass. All right, so I got my carbon, my oxygen, my hydrogen. So now I'm going to start dragging copies of these over there. I don't know why these lines keep popping up still. I turned off smart guides. Oh well. Illustrator insists on having all kinds of blinking lights and things. So there's one carbon back there. And then I'm going to work on this ring first. That's one of the most challenging parts. So again, it's hard to know where the full edges of the carbons are because we can't see the whole thing because of the way they're overlapping. But I can kind of tell there's one back there. Let me hide the fill color of that temporarily. There's one that has an edge up there. Now it's trimmed off partly by that hydrogen over there, and we'll come back and we'll deal with that later. But I'm at least trying to match up that top edge of that carbon. And now I'm going to make a copy of this. By the way, what I'm doing here, for those of you who aren't that familiar with the keyboard shortcuts, regardless of what tool I have chosen, if I hold down the Command key, it brings up the last selection arrow that I had used before. So that's where this white arrow is coming from. And then if I hold the Option key and I click and drag with the Option key held down, it makes a copy of whatever object I'm dragging. So I'm trying to capture that carbon back there. And of course, notice that these two carbons are actually intersecting along a line, and I can see that line right here where I'm pointing with the cursor. So I need to try to figure out how am I going to trim off the edge of one of these atoms so that it follows that line. And this is where I'm going to use my pen tool technique, where I've got that second circle selected. I'm going to click here with the pen tool. It's going to turn into the Add Anchor Point tool. I've already got one down here. There just happens to be an anchor point right about where I want it. I'm putting new anchor points right where these two lines intersect. And then I'm just going to delete this anchor point on the left. When I hover the pen tool over that existing anchor point, it turns into the Delete Anchor Point tool. And now is where that setting comes in really handy. I'm going to use the white arrow and simply drag this over to the left. And I got to drag it really far over. And it's still not exactly on that line, but it's pretty darn close. That's probably close enough. And now if I put a fill back in here, you can see what I've done is I've created that edge where those two carbons intersect. But now I'm going to turn off their fill colors again, because I need to do that again. I'm going to drag another carbon over here and hide its fill color. And that carbon in the background is like totally hidden now. I have no idea where the edges of it are. I just kind of have to make it up and wing it. probably has to come up more like so. Nudge it over and down a little bit. No, I'm realizing if I follow this curve, it's going to come over to about here. So that's about where these two should be intersecting. So let me move that down to that point. And then once again, I'm going to use the pen tool, add an anchor point. Oops. The reason it won't let me add an anchor point is because this circle is actually behind the other one. So when I try to click right there, I'm not actually able to click on the selected circle. So I need to bring to front, need to bring that circle to the front. And again, I'm so used to doing this with keyboard shortcuts, I forget where they are in the menus. Command Shift right bracket would bring it to front. Now that it's in front, now I can actually click on it and add an anchor point. And I'm going to add one down here because this is right about where all of the carbons are intersecting at the center of this ring. Delete these two anchor points and then use my white arrow, drag this out a little bit to kind of follow that curve. And I need to keep doing this, keep taking new copies of my carbon, keep bringing them to front, which I'm going to do with a keyboard shortcut now. Get rid of the fill. Even though we can't see where they actually intersect out here, I'm going to assume that they intersect out there. Add another anchor point here where all of the carbons are intersecting. Delete that anchor point. Take my white arrow, drag this path down. So there's a line back there where you can just barely see where these are intersecting one another. Grab another carbon for that one back there. Once again, hide the fill color, bring to front. And all right, I think I screwed something up here. Okay, did I add an extra carbon? 1, 2, 3, 4. Oh yeah, I added an extra one. All right, like I actually have to delete this one. I didn't realize that one actually comes all the way down to the bottom here. So I actually have to change where these intersect and redo that, but that doesn't take too long. There we go, that's better. And drag another copy over there to get this carbon. Bring that to the front, add an anchor point, add one up here where they all intersect, and delete those points, and again move the edge over a little bit. And then there's one last carbon hiding back there. Now this one we really can't tell where it goes. Again, I'm going to add a couple anchor points. That probably needs to come down a little bit more. And then here I have to decide which one makes more sense to be in front. I'm actually going to send these guys to the back. Arrange, send to back. So now this one is in front of the others. And if I put the fill color back in, you can confirm that. So then add an anchor point here. Delete that one. Move this line around a little bit. And then I can drop the fill color back in here again and see what it looks like. That's not horrible. This one I probably need to move around a little bit. Move that one anchor point down just a smidge, so that all 6 of these carbons are now basically meeting at a central point right in the middle of that 6-sided ring. I'm not going to try to draw the rest of the molecule for you. I just throw a oxygen over here, and I'll throw a couple of hydrogens in. This hydrogen's in the front, this one's in the back. So this one I'll send to back with a keyboard command. But let me hide the fill colors just to see if there's anything. Oh, that one's in the back too. All right. So that's in the back. Again, I just did the keyboard shortcut to send it to the background. But this one's in the front. So I need a third one here, and now I got to bring that back to the front. So I'm going to do arrange, bring to front. So then if we put our fill colors back in these hydrogens. And then I need fill color for my carbon. I'm going to use the eyedropper. I just hit the letter I on the keyboard to pull up the eyedropper so I can select the color for that carbon. But let me hide that again, because I think there was some, yeah, the carbon and the hydrogen are intersecting. So there's the carbon's a little bit trimmed off just very slightly. So I'm going to add an anchor point over here, and I don't need to delete an anchor point. All I got to do is just drag this line back to create that edge right there. And then once again, my eyedropper, pick up that one. Right, so I've got, a lot of the atoms, but certainly not all of them. So then what I need to do is I need to put gradients in these things to actually make them look like spheres. So let me go ahead and make the gradients on these 3 circles over to the right. So I want to make a gradient that looks like a dark gray sphere. And here's how I create radial gradients. And this is another thing I'm a little bit OCD about how I do this. And it's only because I've been doing this for 30 years and I've tried a lot of other ways and this works well. So it works for me. I realize, you may have your own way of doing it, and as long as it looks good, I'm okay with it. But whenever I create any kind of radial gradient, or really any kind of gradient at all, radial or linear, I always think to myself, what is the native color of the object? What color is this object if we had sort of uniform ambient lighting all around the object with no bright highlights, no shadows, nothing like that? What would be the inherent color or the native color of the object? And I want this to be a dark gray. I don't want it to be a super, super dark gray. I don't want it to be 100% black or anything like that, but a fairly dark gray. So I'm going to apply a gradient to this thing. I'm simply going to click the default gradient in the gradient palette. And initially it puts in a linear gradient, but then I'm going to click over here to make it a radial gradient. Click in the gradient palette, change it to a radial gradient. And on this little slider at the bottom of the gradient palette, the left-hand dot, or this is actually what's called the slider, is this little dot. That corresponds to the center of the radial gradient, so the white at the center. And then the black dot at the far right, that's another slider. That corresponds to the black around the outside of the gradient. But I'm going to start by making my midtone first. And the midtone is going to be somewhere just a little bit to the left of the center. So I'm going to add a new slider to the bottom of this little grayscale bar. And I'm going to add it by simply clicking below the bar. That adds a new slider. And this is going to be my midtone color. So this is going to be the native color of the object. So I'm going to stick with that 60% gray. I thought that was a pretty good gray. Notice one thing, this is something else that I'm very OCD about for good reasons. I enter the colors directly in the color palette by typing in the numbers, typing in the numerical values. Oh, and by the way, if anybody looked ahead at the assignment, this is something that should be done in CMYK. So you should actually create a new file. I kind of skipped this step. You should create a new letter-sized image. And I don't care if it's vertical or horizontal. It depends on the orientation of your molecule. But make sure you're working in CMYK. So I always create my colors by entering the CMYK values directly in the color palette. For the love of God, do not click on the little rainbow thing. I hate that. Don't create your colors by just clicking randomly in this little rainbow. You're going to get all kinds of bizarre, hideous colors, and you have no control over what you're getting. It drives me crazy that the default in Illustrator is to just give you the rainbow. I think they should simply eliminate the rainbow. They shouldn't even give it to you as an option. The last thing they should do is make it the default. So always make sure you're showing options so you can actually see the colors. See the crazy numbers I'm getting in there with this? Maybe I'm getting a little crazy in my old age, but there are numerous good reasons to just enter the numbers directly. And if anybody really cares, I'll explain after class, but I don't want to get into that right now. So I'm just entering 0% cyan, 0 magenta, 0 yellow, and 60% black from my gray. So now that I've created my midtone, which is just a little bit left of center on my little bar down here, I want to create the highlight color. And I'm going to click on this existing white dot here, the white slider. If this is a shiny plastic or metallic ball, then we might actually have a pure white highlight. I'm going to assume that it's maybe not that shiny and put a little bit of value in there, I don't know, 10%, something like that. Just a little bit of gray in here. Next thing I'm going to do is I'm going to create my core shadow. And I'm going to use this existing black slider for the core shadow. But I'm not going to leave it all the way over at the far right. I want to leave room to have a reflected light on my object. So I'm going to drag that right-hand slider over to the left just a little bit. And I don't want a solid black core shadow. That's overkill. Now my native color, my midtone color is 60%. So maybe my core shadow might be 75, maybe we'll go a little more than that. 85, that looks pretty good. And then the reflected light, I'm going to add a new slider at the far right, which is going to be a little bit lighter than the core shadow, but shouldn't be as bright as the highlight, or excuse me, shouldn't be as bright as the midtone. So my midtone was 60. Let's make this, say, 70 or 75, somewhere in there for our reflected light. Now, this thing doesn't look like a sphere yet. It looks like a bullseye. The trick to making this thing really look like a sphere is the way you distribute the gradient inside the circle. And to do that, we're going to use the gradient tool. And when I select the gradient tool and I have the fill color of my object active, we get this little thing called a gradient annotator. What I don't want you to do is please don't just click in the shape, because then what happens is we get this weird distorted highlight. It looks like it's sort of shoved up to the left, but we can still see the whole midtone and core shadow and everything surrounding that highlight up there, and it really shouldn't look like that. So the way to apply a gradient to a circle to really make it look convincing, like a sphere, is to first of all imagine the circle is divided into 4 quadrants. So imagine a vertical line running right up and down through the middle of the circle, and a horizontal line running left to right across the circle. And those imaginary lines are going to divide our circle up into 4 equal slices of pie, 4 quadrants. So what I'm going to do is I'm going to position my cursor in that upper left quadrant, somewhere right in the middle of that upper left quadrant. And I'm going to click with my mouse. I'm going to drag down and to the right, right through the center of the circle until I get all the way down to the bottom right-hand edge of the circle, and then I'm going to let go. So this is all going to be one smooth, fluid movement. Click, hold the mouse button down, drag right through the center of the circle, right through the center dot, until I get down to the bottom right edge, and then let go. And now I have a lovely sphere with a highlight surrounded by a midtone, a core shadow that's being created by the equator of the sphere, and then a little bit of reflected light limited down only to the bottom right. Now I can play around with the exact location of these different sliders. If I want this thing to look shinier, I can drag this little diamond and drag it to the left. What that does is it gives my highlight a harder edge, which makes it look more like a specular highlight, which you'd have on something that was shiny and reflective. I mean, I don't really care if you do that or not. That's not a big deal. You can also give a little bit harder edge to the core shadow, which I actually prefer. So I can drag this other little diamond over to the right a little bit. And what that does is it stretches the midtone and scrunches up the core shadow, gives the core shadow a little bit harder edge. So now if I just deselect this, you can see we've got a pretty convincing looking sphere. To create the other ones, what I'm going to do is I'm going to simply use the eyedropper and copy that same. Okay. It's going to let me do that? Yeah, no, it won't. All right. That's weird. Anyway, I'm going to ignore that. So what I've done for the hydrogen down here is I simply copied the sphere in the upper left, the carbon sphere. I'm going to reapply it the same way. Click in the upper left quadrant, drag through the center dot until you get all the way down to the very bottom right edge of the circle, and then let go. Now all I need to do is just change the values of the different sliders to make my white hydrogen. So this time I'm going to go ahead and make the highlight pure white. I'm going to take the midtone. I'm not moving the midtone. I'm simply changing its color. That way all of these spheres are going to look exactly the same except for their color. I need to put a little bit of value in here, so maybe 15%, just so it has, a little something for the highlight to show up against. Maybe we'll go 20, just so it looks better on screen. My core shadow is not going to be nearly this dark. Let's try maybe 40. We can go a little higher than that. Maybe 50%. And then my reflected light, it's got to be less than 50, so we'll try 40 for that. So now I've got a nice highlight, midtone, core shadow, reflected light for the hydrogen. Same thing with the carbon. Once again, I'm just going to grab the one I already created for the carbon. I'm going to position it correctly. So again, click in the upper left quadrant of the circle, drag right through the center dot to get to the bottom right-hand edge, and let go. And now we're simply going to change these colors. Now we're dealing with a little color, so we got to think a little bit more carefully about how to adjust these. It's not just simple grayscale at this point. So I'm going to start with my midtone. And I know that in the CPK color scheme, oxygen is always red. So I need to make this a red. And so I'm going to say, let's try 80 magenta, 80 yellow. Let's go a little bit more magenta. Yeah, 90 magenta, 80 yellow. That works. It's a nice red. My highlight previously was 10% gray. We definitely don't want that. I'm just going to make it a lighter version of that same red. So if we do say 15 and 10, something like that, that's a light pink. Core shadow is probably the trickiest one because I need to make, what would this red look like in a shadow? Obviously, it's going to be darker for one thing. I'm just going to start with a blank slate here, just start with all zeros. Now our midtone was 90% magenta, 80% yellow. One thing you definitely don't want to do is don't just make both of these 100% and 100%, because that's not a shadow version of red. That's just a more vivid, more saturated red. If anything, shadows are less vivid, less saturated than the midtone color. So if anything, this should have actually less magenta and yellow. So instead of 90 and 80, I might do, 80 and 70. So that means it's a little bit less vibrant. I could even go a little lighter than that, 70, 60. But then you can go ahead and add in a bunch of black. And I know when you take painting classes, they always tell you never use black to make things darker, but it's okay when you're working in CMYK. And then my reflected light also needs to be a version of this red, just lighter than the core shadow. I'm just going to drag this other slider off of here and then click and add a new one. So I'm basically starting with the core shadow color and just remove some of that black, and then I get a reflected light color. So then I could go back to my artwork and select all of the carbons, grab my eyedropper tool, and then simply click to apply that gradient from the carbon. The problem with this is that it doesn't maintain the orientation. So I'm going to have to go back and figure out how to apply those gradients to all of those circles with my gradient tool. So for something like this oxygen, where I can see the whole thing, it's pretty easy. I just grab the gradient tool and I use the same approach I showed you before, where I click in the upper left quadrant, drag through the center dot down to the bottom right and let go. That's easy. Same thing with these hydrogens up here. Click in the upper left quadrant, drag through the center dot down to the bottom right edge and let go. Even these ones that are partially hidden, when I select the circle, I can still tell where the upper left quadrant is. I'm going to click there, drag through the center dot, down to the bottom right edge. The highlight is completely hidden, but that's okay. It would be if we were actually able to look at this thing. And then this one up here, same thing, upper left quadrant, through the center dot, bottom right edge. This carbon here, again, we're seeing the whole thing. So I can use the same approach. Click in the upper left quadrant, right through the center dot. Now I have to try to imagine where the bottom right edge would be because part of it's been a little bit trimmed off. So I'm just going to guess it was roughly about here. And that's where I let go. That's where it puts my reflected light. But these guys are going to be a lot more tricky because they've been a little bit more extensively trimmed. Now this one conveniently, when I grab the gradient tool, kind of shows me the outline of the full circle. So I can do the same thing. Upper left quadrant, through the center dot, down to the bottom right edge, and let go. This one, not so much. The circle that's part of my gradient is not lining up perfectly with the circle of my carbon atom. So I have to try to guess, like, roughly where is the upper left quadrant of that circle? Somewhere up here. And then drag down and let go on the bottom right. This one, again, that the circle that pops up with the gradient tool is not exactly perfect. It's pretty close. So click here in the upper left, down to the bottom right and let go. Now this one, here's another one where we still have the entire circle, so this one's easier to figure out exactly where to click initially and where to drag. Oh, now there's one back there that I still have to do. So if I hide my image in the background, you can see what we're starting to get. And then I would have to just make all of the atoms intersect. I'd have to finish doing that. So I mentioned quite a while ago that there are different approaches to this same project. The other approach is to simply put the gradients in at the beginning and try to figure out, where these circles belong. One of the problems with having the gradient in there all already is that I can't even see some of my carbons. I've already hidden some of my carbon atoms in the background. There is a little trick if I want to be able to see the background image and see the outline of this circle at the same time. I don't know if you're aware of this, but under the view menu, you can view the entire image in what's called outline mode. That hides all the fill color, all the strokes, all the gradients, everything. So we only see the outlines. The problem with going into outline mode is that my background image disappears. My ping file is gone. But there's a way to go back to preview mode. There's a way to make one layer go into outline mode while leaving the other layers in the normal visible mode. And the way you do that is in your layers palette, you notice the little eyeball to the left of the layer. If I simply click on that, the layer is hidden. If I click on it again, the layer comes back. But if I hold down the Command key, and I assume this would be Control in Windows, hold down Command and click on the eyeball. That layer is now in outline mode, while the rest of the image is in preview mode or visible mode. So the advantage to this is that I can leave the gradients in the circles. I can see the outlines of the circles, so I can simply copy them and figure out, where these things are going to be overlapping or intersecting. And just like I did before, add anchor points, delete anchor points, drag that line out, make another copy, make sure to bring it to front, add anchor points, delete anchor points, match up that line, and so on, and keep going. Now, I'll be interested to see what this looks like when I take a look at it in a second. Let me throw one more in here. Send that one to the back. Delete this point. Let's see. One thing I'm curious to see is how much it's screwed up my gradients. To get this layer to be visible again, I just do the same thing. I hold the Command key down and click the eyeball, and it comes back. And I don't know, it may have actually worked better. Let me explain what I mean here. This is another thing that they changed in Illustrator that pissed me off. every time they come out with a new version, they screw up something that used to work perfectly fine. It used to be in the past that if you had an object that like this that had a gradient in it, you could add a couple of anchor points and delete anchor points, and it would leave the gradient exactly where you put it. So you could have the highlight, the midtone, the foreshadow, and the reflected light exactly where you wanted them. And as you deleted anchor points, it didn't suddenly move everything around. I mean, you couldn't see the highlight if I deleted these anchor points. And that's, I don't know. At some point they changed it and it would totally reposition everything. It is moving the highlight and the shadow around a little bit, although not as bad as it used to be. But you'd still have to go back to this and try to envision, all right, where would the upper left quadrant of this be if I still had a full circle? It's up there someplace, and then drag. You still have to redistribute the gradient. So even these here, I have to go back and reposition them. Try to imagine, you know, where would the highlight have been if that was still a full circle, and then reposition them. So I guess for this reason, because you still have to go back and fix all the gradients anyway, maybe the first approach that I showed you, where you just draw everything as flat color circles and then add the gradients at the end, that may actually be a little bit more efficient way of doing this. Last couple of little things, just some specifications for the project itself, and a couple of little, I don't know, warnings or reminders. You should, before you submit this to the My Courses Dropbox, and this is something to always keep in mind in the future when you're working on any project for school, especially when you're out there in the real world doing professional stuff in Illustrator. If you've used the margins to create a bunch of parts and pieces and junk, like I've got my various little spheres over here, they're outside of the print area, but they're still part of the file. And you will piss off a client if you leave a bunch of extraneous crap out in the margins beyond the print area. So always, always, always get rid of any extraneous junk that you've left in the margins, or really anywhere, you know, on the image. The other thing to always do, and of course, this is something you have to wait until the very end, but you want to make sure you get rid of any placed sketches, reference images, reference files, like these placed ping files. It's not enough to just hide the layer they're on, because they're still there. They're still part of the file. And the reason that this pisses off clients is if you're sending this to a publisher, like a textbook publisher, a journal publisher, they're going to drop your image into a page layout, and then they're going to run something called pre-flight software, which is going to go through the entire document, like an entire textbook, literally go through and make sure that every font is there, and they're going to make sure that there are no issues with any of the illustrations. And if you mix RGB and CMYK in a file, it's going to flag that. If you have like an RGB image in the background, even if that RGB image is hidden, it's going to flag that. And then that's going to take their time to go and fix your mistake. And so they won't be happy. So don't just hide your ping files. You know, obviously, again, you have to wait until you're completely done with the project, but make sure you delete them. And while you're at it, delete the layer they're on, even though that the layer doesn't make a big difference, but at least that way you make sure you've gotten rid of, you know, any random JPEGs that you may have dropped into the background.